Welcome to Crack Academy with Abby, Lily, and Caitlin. Today we're going to be learning about area approximation using rectangles. Okay, so the function we're using is y equals x squared plus 2, which is right there. We're going to use 4 rectangles on the interval 1 to 3. So we need to find change in x, which is 3 minus 1 over 4, because this is where we start, end, and how many rectangles we have. So that turns into 1/2. And then we're going to draw the rectangles, which is right here. Okay, so we see the 4 rectangles, and with a left Riemann sum, we're underestimating the area because these little spaces we're obviously not accounting for. So just remember that in the end. Okay, and then the class welcomes Caitlin Waldansky.
Thank you. So the next thing we're going to do for our left Riemann sum is we're going to find the area under the curve. But before we can do that, we have to find the area of each rectangle individually. And to find the area, it's just our base times our height. And we already found our base up here, which just is our change in x. So first, we're going to do f of 1, since that's our first point. F of 1 times our change in x. But for right now, I'm just going to write it as this so we can see it through. And then our next is f of 1.5, since that's our next point, times our change in x, plus f of 2, plus, or times change in x, plus f of 2.5 times our change in x. So this is going to be our area as a whole, but first we have to find the points of each of these individually, which our f of 1, for example, would just be the y value of 1 on the graph. So f of 1 is 3, and we multiply that by our change in x, which is 1/2. And we do this for all the points. So f of 1.5 is 4.25 times our 1/2 plus our 6 times 1/2 plus f of 2.5, which is 8.25 times our 1/2. And this will give us our area. And to finish us off, the class has Abby Delane.
Okay, so now we're gonna make a table. We had our x was 1, 1.5, 2, and 2.5. And we already found our y values. So the y value for 1 was 3. For 1.5 it was 4.5. And for 2 it was 6. And for 2.5 it was 8.25. So now we can make our equation to find the area. And since we multiplied it by 1/2, we can factor it out. And we put all of our y values. So 3 plus 4.25 plus 6 plus 8.25. And we can go ahead and then next we have to add all these up, which is 21.5. And we still have to multiply that by 1/2. And that is 10.75. That's our final answer. Next, we just did the left, and now we're going to do the right. So instead of starting from the left like we did, we're going to start from the right and make our rectangles over our line like this. And since our rectangles are over our line, it's going to be an over approximation. So then for our equation, we do the same thing with like the table and with the 1/2. And instead of using 1, we're going to use 3 because we started from the right. So it'll be 11 plus 8.25 plus 6 plus 4.25, and you're gonna get 14.75. And then the next approximation is the midpoint. And wait a second.
And the last sum approximation is the midpoint. And for midpoint, instead of calculating it from one side, it's actually from the middle of each rectangle. And for this, in the table, you'd have to use the 2. And since we have 4 rectangles, it would be these 2, these 2, these 2, and these 2. And then for that, you add the 2 x's and divide it by 2 for each point. And that'll give you your midpoint area. And the midpoint area is the most accurate because it's in between the left and the right, and it accounts for all parts of it and not an overestimate or underestimate.
Brought to you